Hello again, everyone, and welcome to the next lesson in our Cosmic Adventure lecture series. My name is Dr. Valerie Rapson, Assistant Professor of Physics and Astronomy at SUNY Oneonta and past Director of the Dudley Observatory. Today we're going to talk all about the Messier Catalog. Now, you might be familiar with some of these objects, especially if you're into amateur astronomy or if you've ever been to a star party before. Undoubtedly, somebody has pointed out an M object like M31 or M42. These are all different star clusters, galaxies, and nebula that are part of the Messier Catalog, originally put together by Charles Messier in the late 1700s. Today we're going to do a brief history of this catalog. We'll start with an introduction to Charles Messier and his career in astronomy, and then we'll go through a whole bunch of the Messier objects, talking a little bit about their original discovery, as well as some of the science that we now know about each of them. And then we'll wrap up our lesson today talking about Messier marathons, this fun event that you can participate in that usually occurs around March of every year, where you can go outside and try and spot as many Messier objects in one night as possible. Let's begin with a brief introduction to Charles Messier. Messier was a French astronomer in the late 1700s who was originally hired by the French Navy not to do astronomy, but actually to copy maps of China. He had really good penmanship, he played close attention to detail, and they needed some maps duplicated, so they hired him to copy over and rewrite these maps. During his career, he got to know the astronomer of the Navy and showed some interest in doing astronomical observations. So from the mid-1750s to about the mid-1770s, he was the assistant astronomer to the French Navy, and he really focused not on general observations of the night sky, but rather on comet hunting. In 1758, it was predicted that Halley's Comet would return, and the astronomers at that time didn't fully understand how comets came back, that they were periodic. So nobody was really sure if this prediction that Halley's Comet would return would actually happen. So one of Messier's first tasks was to search the sky along the predicted path of the comet to see if he could see Halley's Comet in 1758 or early 1759. Eventually, he did observe Halley's Comet, but during this time frame, he observed a lot of other objects as well, which ultimately became part of the Messier Catalog. Now, over his career, he's credited with a lot of discoveries. Specifically, he discovered 44 comets throughout his lifetime, and later on, I'll share with you more about different objects that he was credited with discovering that are in the Messier Catalog. He continued to work as the astronomer for the French Navy after the original astronomer passed away around the mid-1770s, all the way up through the late 1790s. So Messier conducted most of his work at this place called Hôtel de Cluny in Paris, France. And we don't know much about the telescopes that he used. Unfortunately, he didn't provide a ton of detail about the diameter of the optics or the style of the telescopes. We can guess based on our knowledge of telescopes and telescope technology at the time that most of Messier's telescopes were around 3.5 inches to 8 inches in diameter. When we take a look at some of his notes later, you'll see him mention telescopes that are 1 to 5 feet long. And what he's referring to there is the focal length, the length of the telescope, not the diameter of the optics. It would have been pretty amazing for the time if they had a 5-foot wide piece of glass or a mirror inside of one of these telescopes, but we have to wait a couple hundred years for that to happen in astronomy. Now there are some pictures and paintings of this original observatory. On the left-hand side there, you see a depiction of Hôtel de Cluny in the 1700s. And at the very top of the tower there, you can see that there's a dome in the background. And at the top of the tower, that is where the official observatory was. That is where Charles Messier made a lot of his observations. Now we can get a sense of what it looked like with some more modern paintings and photographs. Here is a picture of Hôtel de Cluny in 1839. This is a painting of it. And at this point, the observatory was removed. You can see that there is no longer this dome-shaped object at the top of the tower here. So at some point in history, the observatory was removed. And the building still stands today in France. Here is a modern day picture just off of Google Maps of what this location looks like, where the observatory would have been, again, right up here at the top. So Messier made his observations from Paris, and remember, this is 1700s. This is long before there was a lot of city lights and city glow to worry about. So his view of the night sky was much, much better a few hundred years ago than it would be today. So throughout his career of comet hunting, Messier cataloged and wrote down notes for any objects that he spotted in the sky that were not comets and not point sources. That is, not just a single random star in the sky. Many of the objects that he observed were original discoveries. They had never been seen before. And some were duplicate discoveries, but Messier was really the first person to collect up all of these non-star and non-comet-like objects and put them together in one nice catalog, nice list for reference. Today, the Messier catalog contains 110 objects that include star clusters, galaxies, supernova remnants, and planetary nebulae. And you can see a picture of the front page of the second version of Messier's catalog, which was published officially in 1784. And at the time, it was called the Catalog of Nebulae and Star Clusters. Now, remember that Messier was a French astronomer, so all of the original documentation is in French. But throughout the presentation, we're going to take snippets from this catalog and translate them to English, so you can see some examples of what Messier wrote about different objects throughout his career. Here is an example of an interior set of pages of the original Messier catalog. And again, it's in French. I don't expect you to be able to read it necessarily, but I wanted to show it to you just so that you understand the types of things that Messier wrote down and what the original catalog really looked like. On the left-hand side, we have the date of the original observation. That's the first column, where we've got month, day, and year. Second column is the Messier number, where everything is just in order here. So the object that became M1, M2, M3, and so on. The next couple of columns are basically celestial latitude and longitude, or the right ascension and declination, the position of the object in the sky. The first two columns are different ways that astronomers would write the right ascension, either in hours, minutes, seconds, or degrees, minutes, and seconds. And then declination is always given in degrees, minutes, and seconds. At the end of the numbers, you can see that there's a letter, A and B. This represented whether the declination value was positive or negative. So A was negative and B was positive. And this just tells you whether the object was north or south of the celestial equator. The final column here represents the diameter of the object, how large the object appeared in the sky. And depending on what the object was and the observation that Messier was able to do, sometimes he lists a diameter, how large it appears on the sky, and sometimes he doesn't if it was difficult to tell exactly how large it was. The right-hand side of the book here again shows the Messier number, just for ease of transitioning between page 1 and page 2. And then this is a copy of Messier's original notes about the object. They often include a brief description of what he saw. If he knew that somebody else had discovered the object prior to him, he would often note that. And he might also make some other notations down about how he observed the object. And this is the type of stuff that we're going to translate for you as we go through and take a look at the catalog. Now, one thing I want to cover before we actually get into some details and examples from the catalog is just to put all of these observations in historical context. Remember, Messier made his observations in the late 1700s, and the astronomy that we were able to do in the late 1700s is far different than the astronomy that we're able to do today. First thing to keep in mind is that there are no pictures. Photographic plates for telescopes were not invented until the late 1800s. So what we have are just handwritten notes and descriptions of what Messier and his colleagues saw, and the occasional sketch of some of the really interesting images, which I'll show you later on. So as I show you pictures, I'm going to be showing you modern day pictures, but I'm going to try and show you something similar to what Messier would have seen, and then we'll take a look at, Hubble quality images or something like that, and talk about the science that we understand today. Now, remember that we didn't really understand what these objects were when Messier was looking at them in the sky. He often referred to most objects as nebulae because they looked sort of nebulous and cloudy in the sky, even if they technically were something like star clusters or galaxies. Edwin Hubble determined that what was often referred to as spiral nebulae, that they were actually galaxies outside the Milky Way, but he didn't make this discovery until 1924. So Messier obviously, saw a lot of galaxies, but didn't know that they were galaxies outside the Milky Way. We also didn't know that some of these nebulae were actually remnants of dead stars. That wasn't something where the connection was made until Walter Baade in 1938. So the word nebula is used frequently, but you have to remember that it really means just any object that we don't really know what it is. It has some sort of cloudy or nebulous structure. And we also have to remember that Messier's telescopes were not nearly as good as the telescopes that we have today. So when he was making his descriptions, he may not have seen anywhere close to the detail that we see in things like Hubble photographs. So there are definitely some things that he missed and some things he called nebulae that really should have been called star clusters. But again, he didn't have the resolution. He didn't have the quality of telescope to be able to decipher all of these details. So as we go through the Messier objects today and we take a look at Messier's notes, just kind of keep all this in mind, that this was very early astronomy that we were doing, and the first time that some astronomers had observed these objects in the night sky. All right, so what we're going to do now is take a look at some of the different Messier objects in the catalog, and we're going to go roughly in chronological order. As you'll see, not all of the Messier objects are listed in chronological order, at least not initially. But all of this will become clear as we start to realize how and when Messier started to put together his official catalog. The very first object that Messier observed and jotted down notes for was what we now call M32, and it's a satellite galaxy of the main galaxy Andromeda. M32 was originally observed by Messier in 1757, and the official notes that made it into his catalog actually came from a later observation in 1764. On the slide here, and for many of the upcoming slides, you're going to see a copy and a translation of Messier's notes. They contain the date of the observation, the position and the diameter of the object if it's known, and then the description that Messier jotted down in his notes. On the right-hand side, we're going to show some pictures of these objects. In this image here, you can see the main Andromeda galaxy. We now call that M31. And there are actually two satellite galaxies in this image, M32, the one we're talking about down here, the little one, and this is now M110. We'll tell the story of M110 towards the end of this presentation. If we take a look at Messier's notes, you can see that he described M32 as a small nebula without stars, below and just minutes of arc from the belt of Andromeda. This small nebula is round, its light fainter than the belt, and then he makes some notes about Gentile, who was actually the first person to have observed this object. So even though this was the first observation that Messier made of an object that wasn't a comet, it ended up later in the catalog once he decided to kind of put some objects in order, and also he wanted to include this with the Andromeda galaxy. Now, the picture on the right is kind of a wide field of view modern day picture. Messier probably had a view of M32 that looked a little bit more like this. So you can imagine kind of zooming into that previous picture and only looking at that small elliptical galaxy, which is the yellow fuzz ball here. So this is the small nebula that he originally observed, with the full Andromeda galaxy somewhere up and above, up to the right of this picture. So M32 was the very first object in the catalog. The next one that he observed is M1, or Messier 1. And now we're going to start to go a little bit more in order of the numbers in the catalog. M1 we now know is the Crab Nebula located in the constellation of Taurus. And a lot of these objects got their colloquial names, like the Crab Nebula, a little bit later on. So you won't see those names referenced in Messier's catalog. He just called them nebula or whatever type of object it was. M1 was originally observed by Messier in 1758. He described it as a nebula over the southern horn of Taurus, contains no stars, but the light is whitish and tapered, like a candle flame. And if I look at the picture on the right, I can kind of see that. This is M1 in the sky. It would have been nice and black and white to Messier's eyes, and it does kind of look like a nebulous candle flame. We now know that M1 is actually a supernova remnant from a supernova that exploded in 1054. So you've probably seen this famous image of the Crab Nebula taken by the Hubble Space Telescope. We can see a lot of the details and we can see the colors representing the different materials that make up the supernova remnant. But all of this was determined and discovered in much more modern times. Now, the interesting thing about M1 is that Messier and others, when they were doing their observations, they saw the nebula. But if we go back to historical astronomy records, like back to the year 1000 and look at the Chinese astronomy logs, we actually see notes of what they call a guest star, or what we would now call a nova in the sky. The Chinese astronomers were constantly observing the sky and noting any changes that they saw, specifically any stars that just appeared or got really bright in the sky. And there is, at the same location that Messier noted the Crab Nebula, that the Chinese astronomers noted a guest star or a new bright star in the same location. And it turns out that what the Chinese astronomers saw in 1054 was the original explosion. And what we see today as the Crab Nebula is the supernova remnant, the leftover bits of the supernova explosion. Basically, you can think of it like the star spitting its guts out into the galaxy. And now we get to see those guts traveling outward into space. So this is really cool to kind of put the science together with the observations. But at the time, Messier just saw it as a beautiful nebula in the sky. The next object we'll take a look at here is M2. M2 is a globular cluster within the constellation of Aquarius that was observed by Messier in 1760. Messier said that it was a nebula without a star in the head of Aquarius. The center is brilliant and the surrounding light is round. She resembles the beautiful nebula located between the head and the bow of Sagittarius and is very well seen with a telescope of 2 feet placed upon the parallel with Alpha Aquarii. So there's some interesting things in his descriptions here. First, he calls the star cluster a nebula because, as you can see in the picture here, again, more modern day picture, you can imagine that with a small telescope, you might not be able to discern the fact that those are individual stars together. So to Messier, it probably looked more nebulous with a very bright center, as you can see. Notice in Messier's notes that he also refers to these objects as she's. Nebula is a feminine word, so he just referred to any nebulous objects as women, as she or her. And the note there about being similar to another object in Sagittarius, that other object, which is now called M22, is another globular cluster within the constellation of Sagittarius that he actually observed 4 years later. So as he was compiling his notes for the final catalogs, he would actually, go back and reference other objects and make some comparisons that he saw, even if the objects weren't observed in the same year or at the same time. But once you have the catalog, you could go back and look at any of the objects that you want, potentially in a single night, depending on exactly where the objects are. So he made a lot of references to other Messier objects. And then finally, I think this is the first note where he marks the size of a telescope. So when he says a telescope of 2 feet, again, he doesn't mean the diameter of the optics. He's talking about the length of the telescope. So the focal length changes. So you'll see references of telescopes between about 1 and 5 feet. Now, Messier 2 was spotted because he was looking specifically for Comet Halley, and Messier 2 falls along the predicted path of Halley's comet in 1758. So he happened to spot this object again because he was looking for Halley's comet, didn't see the comet necessarily, but saw this globular cluster. Now, if we zoom into the globular cluster, again, using the Hubble Space Telescope, we can see that it is indeed, thousands and thousands of stars. And globular clusters are really great for astronomers. We can learn a lot about our location in the Milky Way galaxy by measuring the distances to globular clusters, which tend to group near the center of the galaxy. And globular clusters also tend to exist above and below the galactic plane, more so than within the galactic disk. So these globular clusters often contain a lot of older, lower mass stars, which is why they appear kind of white and yellow in a lot of the pictures. Next up is Messier 3. And this was the observation that really triggered Messier to become serious about putting together a catalog of all of these interesting objects he had discovered in the sky. Messier talked about this object as a nebula discovered between the ox herd or Bodes and one of the hunting dogs of Hevelius or Canis Venatici. He said it contains no star, the center is brilliant, and the light fades imperceptibly. It's round, and in a good sky, you can see it with a telescope of 1 foot. So this object was small, but very bright. He was able to see it with a shorter focal length telescope that would have been looking at a larger view in the sky. The original observation was in 1764, but you can see in his notes there were some later observations in comparison to objects that he saw in the late 1770s and early 1780s. Just as a reminder, these notes are from the catalog, the second version of the catalog he published in 1784. So you'll see comparisons to objects up through that date. To give you a more close-up view of M3, here's a nice Hubble Space Telescope view of this object. Again, you can see lots and lots of stars scattered about there. And as we mentioned, Messier 3 really got Messier thinking that he not only needed to start making a list and be extra careful about all of the observations he was making to make, precise notes of them, but also to go to other catalogs that had been developed at the time to see if he was making original observations or if these objects had been discovered before. Because he wanted to credit people appropriately, but he also wanted to know if he was the first one who had ever noticed these objects in the sky. So after the discovery of M3, he started to catalog all of the interesting objects that were noted in the sky. And in 1764 alone, he independently discovered 19 different objects. These are all objects that nobody else had ever seen before in the sky, at least in catalogs that he was able to acquire in the late 1700s. By 1769, he had cataloged 41 objects that we now call M1 through M41. And to quickly show you a couple examples here, some of these objects were things like galaxies. So we've already seen the Andromeda galaxy, but here's a nice view of it again. This became M31. The small galaxy below, which is actually at the top of this picture, that was the galaxy that was M32. And then this bright galaxy down here, which is another satellite galaxy of Andromeda, that's what became M110. Messier was not the first to see the Andromeda galaxy. Nor was he the first to see the Triangulum galaxy, what we call M33. Both Andromeda and the Triangulum galaxy are both part of what we call the local group. a collection of galaxies that includes the Milky Way galaxy that are all faintly gravitationally bound together. So they're kind of clustered together in space if you were to kind of zoom out and think of our whole universe. This is basically our local neighborhood of galaxies. So Messier spotted a handful of galaxies early on. He also spotted some nebulae. So this is the Dumbbell Planetary Nebula, and the yellow star there represents that Messier was the discoverer of this object. We now know that this is a planetary nebula, basically what's left over after stars like our sun die and release their outer layers into space. So he was the first person to spot this planetary nebula, although it would take a couple hundred years before we actually understood what it was. And he also spotted other nebula that didn't have anything to do with dying stars. The right-hand side, that's M20, or the Trifid Nebula. The colorful gases that you see there are actually what we call an H2 region, an area that is quite warm in space where you have ionized hydrogen gases. And over time, that gas is going to cool, it's going to start to coalesce, and gases and dust will come together, ultimately to form new stars. So both of these true nebula were original discoveries by Messier. And finally, Messier also discovered a bunch of star clusters. This is M11. We now call it the wild duck cluster. The cluster is mostly those blue stars at the center, along with some around the background. Clearly, this cluster is in a region where there are tons and tons of both foreground and background stars. That was not an original discovery by Messier, but the next two were. This is M7, Ptolemy cluster, and M6, the butterfly cluster. So named because if you squint, you can kind of put the stars into the pattern of a butterfly. It does take some imagination, but sort of looks like that in the sky. So these three objects, these are all what we call open clusters. They're a little bit different than those globular clusters, which literally look more like globs of stars in the sky. Open clusters contain fewer stars than globulars. The stars are generally a bit more spread out, and we tend to find them within the galactic plane, within the disk of the Milky Way galaxy. That's why there's so many foreground and background stars. We're looking through the galactic plane where there's tons and tons of star formation happening. So we have a lot of stars to look through, and then these brighter ones often are younger stars that have collected together in a group, often formed from the same original nebula in the sky. So as Messier was making his observations in 1764, he came across a unique object that wasn't common in the Messier Catalog. Here you see M40, which is not a star cluster, a nebula, or a galaxy. It's actually just a simple double star, or a binary star system. And it's the two stars that are close together at the center of this picture here. Messier generally didn't include these double or binary stars in his catalog because they weren't really unique. There's a lot of double stars in the sky. But the reason that he included this is because he was actually searching for a nebula that was noted by Johann Hevelius in the book Figures of Stars that was originally written in 1660. As Messier was looking through old catalogs to see if he was the discoverer of some of these objects that he was seeing, he found notations of other nebula, and he wanted to go see if he could spot it. Well, when he looked at the position recorded in this book for the object, some nebulous object, he couldn't find a nebula, but he found these double stars. You can see in his notes that he said, two stars very close to each other and very small, placed at the rise of the tail of the Great Bear, Ursa Major. So this was a double star within the constellation of Ursa Major. You can see that he says, in seeking the nebula placed over the back of the Great Bear, reported in the book Figures of Stars, Messier could not see, and he has observed these two stars. So he included these in his Messier list, not because they seemed to be an interestingly unique object, but because he was trying to show that there wasn't a nebula at the recorded position from this catalog 100 years prior. Now, for modern astronomers trying to put all of this together and understand what Messier was doing, it really kind of confused us. And it was actually really difficult for modern day astronomers to figure out what M40 was. I mean, it was included in his original catalog, but when we go back to try and observe these objects, we had trouble figuring out that what he was referencing was this double star. It actually wasn't until 1966 when an astronomer named John Mallas really made the connection that this double star, which we call in more modern day catalogs Winnicky 4, was actually the Messier object that Messier was describing. Winnicky 4 was originally noted in catalogs in 1863, and then we made the connection that it was really M40. So there's a lot of interesting history like this with the Messier catalog, trying to figure out what some of these objects were, because it's not immediately obvious sometimes what the objects were that Messier saw. So the first version of the Messier catalog was published in 1771, and right before publication, Messier decided to add 4 more objects that we now call M42 through M45, likely because he wanted to have the most comprehensive catalog of non-stellar objects for the time. He knew that M42 through M45 were not unique discoveries of his own, but he knew they existed, he had observed them, and he wanted to make sure they got included in the catalog so that his would be bigger than any catalog before. So to show you some quick modern pictures of these objects, M42 and M43 are actually part of the same famous object called the Orion Nebula. So the Orion Nebula sits just below the belt in the sword of Orion in the sky. Messier saw the large nebula here, that's M42, and M43 is actually this dust lane and nebulous feature here. M44, the Beehive cluster, you can see that is just an open cluster of primarily young, hot blue stars in the sky. And M45 was the famous Pleiades on the back of Taurus the bull. Both the Orion Nebula and the Pleiades are very easily visible in today's sky, even without a telescope. And you might have even seen them before with your own eyes. Now I want to show you one really cool picture here. This is one of the few sketches that Messier made of the objects that he observed, and it's a sketch of M42. So on the right-hand side is a scan of the original sketch, and on the left-hand side is the picture from the Hubble Space Telescope I just showed you, but it's rotated, essentially flipped upside down to match what Messier was seeing in his telescope. So you can kind of make direct comparisons more easily. And if you look at Messier's sketch, you can see the main bright nebula here, a collection of bright stars that he noted at the center. That's called the trapezium. That's these bright stars that you see here. Lots of nebulous, cloudy material that extends outwards. And if you look at his sketch on the bottom there, this is what he labeled as M43. Now, when you look at the Hubble image, you can see that that region of sky, which is just this bright patch down here with the dust lane to the right, that is all part of the Orion Nebula. But his telescopes did not provide anything near the quality of the Hubble Space Telescope. So to Messier, it looked as if these objects were 2 separate things, which is why they have 2 different numbers in the catalog. M42 for the main nebula and M43 for the small portion of the nebula at the bottom. So that just kind of shows you, why there are these 2 different numbers for the same object. But again, we didn't know they were same objects until a few hundred years later. Messier did not make a lot of sketches of the objects. He did M42. I believe he also did the Andromeda Galaxy as well. But really, he was just noting down what he saw. He didn't take the time to make these precise sketches, which is too bad. It would have been really nice to see what he actually saw at the time for each object. After the publication of the original catalog, Messier continued to make observations of the night sky. We won't have a chance to talk about every single object that he saw, but I am going to point out ones that have some interesting science behind them, or ones that have an interesting story. And speaking of interesting stories, that brings us to Messier 47 and Messier 48. Both of these are open clusters in the constellations of Puppis and Hydra. So M47 is in Puppis, M48 is in Hydra. These were both observed in 1771, but Messier was not as careful in his observations, and he actually recorded the locations of them incorrectly. On the bottom here, you can see a modern day photo of M48. These stars are just a collection of stars in the open cluster. And this is the original notes from Messier. Date, location, and it just says clusters of very small stars without nebulosity, short distance from 3 stars that are at the start of the tail of the unicorn Monoceros. Now, when modern astronomers again went back to try and observe the Messier objects, they looked at this position, right ascension and declination, and they couldn't find anything. They couldn't find a nebula, a star cluster, nothing. And it wasn't until 1959 that astronomer T.F. Morris was comparing the description that Messier wrote with objects that were noted in other catalogs, specifically William Herschel's catalog published in 1786. And he realized that there were 2 objects at different locations in the 2 catalogs, but they were described in almost exactly the same way. And what Morris realized is that Messier just made a mistake in writing down the declination. And his declination of -1 degrees should have actually read -6 degrees. He was 5 degrees off from the correct position in the sky. Now, this actually makes some sense, being exactly 5 degrees off, because Messier was using both star charts as well as reticles to read the positions on the actual wheels of the telescope. And it's likely that Messier would position himself to a certain degree value in the sky based on a star chart, and then read the exact position, the arc minutes and arc seconds, or the minutes and seconds, more accurately off of the telescope. These original star charts that he was using had tick marks every 5 degrees. So it's very likely that for this object, he accidentally counted 1 too few tick marks and marked it down as -1 degrees instead of -6 degrees, and then just trusted his observation of the star chart without confirming it with the actual telescope. So we're pretty sure that M48 is indeed this cluster. There was a similar mistake, a negative sign error with M47, which makes us believe that it is indeed the open cluster described before. So as careful as Messier was, he did make some mistakes, and as you'll see, this was not the only mistake that was made when making this catalog. Messier 49 is next. This is an elliptical galaxy in the Virgo cluster of galaxies. In the picture here, M49 is this object right in the center. It was originally discovered by Messier, and it's actually the first galaxy that was ever observed within the Virgo cluster of galaxies. So the Virgo cluster is a group of galaxies similar to the local group, but outside of the local group. So if you think of our local group as the neighborhood, the Virgo cluster is the next neighborhood over, which could all be part of a galaxy supercluster, which might be thought of like a city. And then you've got your different neighborhoods, your different clusters within that big city, within that big supercluster. So the Milky Way is in the local group. The Virgo galaxy here is part of the Virgo cluster, and both the local group and the Virgo cluster is within the Virgo supercluster of galaxies. If we take a look at this galaxy at a little higher detail, you can see that it is a bright yellow galaxy. Elliptical galaxies are not like spiral galaxies. They contain mostly older stars with very little gas and dust, which is why they often look fuzzy and yellow. And a picture like this can really show you why Messier would have just called it a nebula. It looked like a glowing gray or maybe even yellowish nebula to him in the sky. So this was the first observation of a galaxy in another galaxy group. Messier 51 is one of my most favorite things to observe in the sky, and it's now called the Whirlpool Galaxy. The main galaxy was originally observed in 1773 by Messier, and the companion galaxy, which if you look at the picture, this would be the main spiral galaxy, and this would be the companion galaxy here. That little secondary galaxy was discovered by Messier's assistant, Pierre Méchain, in 1781. So the original notes that were included in 1774, originally observed in 73, but early 74 is when the notes were included. You can see that he references Galaxy A, which is the big galaxy, and there's an addendum later on that includes Galaxy B, the companion galaxy. Galaxy A is a very faint nebula without stars. He wasn't able to actually see individual stars or even really spiral arm structure very well in his images. And he noted that this was near the ear of the greyhound, Canis Venetici. And there's some information about, how bright it is and where it is in reference to the tail of Ursa Major. And he also notes that it cannot be seen without difficulty with an ordinary telescope. And it's near a star that was fairly bright, 8th magnitude. It's not bright enough to see with your eyes, but maybe bright enough to kind of, outshine some of the nebulosity that he would have tried to see in the galaxy. There's some notes here later. You can see that it says it is a double, each with a bright center away from one another. Both atmospheres touch. One is fainter than the other. So you can tell that in these early observations in 74, he kind of saw two objects, but it wasn't until Méchain's observations in 1781 where they really understood that these were kind of two separate, distinct objects. And we now know that the Whirlpool Galaxy is a classic example of what we call galactic cannibalism. That's when a large galaxy, often a spiral galaxy, gets close enough to another one, gravitationally interacts, and starts to consume or pull material away from that secondary galaxy. Here's a really lovely image, nice Hubble image of what's going on here. Again, the main galaxy, you can see the big spiral arms pulling material away from that smaller galaxy. We think this happened pretty frequently in the early universe, not as much today because the universe has expanded and the galaxies are a bit more spread out. But early on, the galaxies were a lot closer together, they likely interacted, and there was a lot more galactic cannibalism then than there is today. So this was the first observation of two interacting galaxies in the sky. As we continue to go through the Messier Catalog, we start to notice that a lot of Messier's observations from the mid to late 1770s were of objects that were far fainter than the ones included in the original version of the catalog. This suggests to us that his telescopes and the optics slightly got bigger and improved over time, allowing him to see these fainter objects. He published a supplement to his original catalog in 1780 that include all objects up through M68. And here I'll show you just a couple of my favorites. Here we've got M57, the Ring Nebula, another great example of a planetary nebula where a star like our sun has ended its life and shed its outer layers. Here we have M58, a barred spiral galaxy. That is a galaxy that shows big spiral arms and a straight-ish line of light that crosses through the center across the location of the supermassive black hole. That is the bar in the barred spiral galaxy, and I believe M58 was the first barred spiral galaxy to be noticed. And then another favorite, the Black Eye Galaxy. This is a spiral galaxy that's seen a little bit more edge on, and there is a lot of dust and gas and active star formation happening in this galaxy. So it looks very dark on one side and a little bit brighter on the other, just because the stars from the center are illuminating the opposite side a little bit more. But just kind of a really neat and beautiful galaxy to look at. So these were just some examples of the fainter objects that Messier was able to see. After publishing the supplement to his catalog, Messier again continued to make observations, and in about 9 months' time, he observed M69 through M100. These were all observed between August 1780 and April 1781, and most of them were galaxies that were really faint, tens of millions of light years away. Now, again, Messier didn't know that what he was observing were other galaxies, and he had no idea that they were that far away. But it's really interesting to see some of the first observations of these really, really distant galaxies. An awesome example of these observations is M81 and M82. These are two different galaxies that are close enough together, both visually in the sky and physically in space, that you can usually see them in the same view with a single telescope. So if you point a small telescope at this region of sky, both M81 and M82 will appear in the field of view at once. The galaxy on the left is a classic spiral-armed galaxy. M82 is what we call a starburst galaxy. I'll get to that more in a moment. But modern day measurements have shown that these galaxies are only about 150,000 light years apart, which is actually really close when we talk about galactic scales. So the two galaxies are likely interacting, and any collisions or interactions between these two galaxies is likely what triggered M82 to become one of these starburst galaxies. If we zoom into M82 and take a look with the Hubble Space Telescope, you can see that that's what the galaxy looks like. The main galaxy is this line here, and then there's all of this reddish colored material, mostly representing hydrogen gases, where there are bursts of star formation within these nebulous regions. This again is likely because M81 and M82 have interacted. Maybe some of the material was shared between the two galaxies, or the gravity just disrupted M82, causing some nebulas to collect together and collapse and trigger a bunch of star formation. So M82 kind of has this look like something violent is happening near the center. And that is indeed true. These starburst galaxies are ones where we literally have bursts of active star formation. Tens of thousands of stars are all actively forming at once. So these are really interesting galaxies scientifically, but they're also very beautiful to view in the sky with a small telescope. The final version of the original Messier Catalog was published in 1784. All of the information for this publication actually had to be turned in by 1781. And as you just saw, Messier had completed observations of objects up through M100. But he and his assistant wanted to make sure that they had the largest and most complete catalog for publication. So Pierre Michon added 3 more objects, M101 through M103, right at the end before the deadline. Unfortunately, he wasn't very careful about his observations, and in the case of M102 and M103, he didn't even include exact positions in the catalog. And Messier didn't have a chance to confirm these observations either before they were submitted for publication. As you'll see in a moment, this turned out to be a big problem and created a 200-year debate throughout history about these two objects. But before we talk about that, let's talk about M101. M101 is the Pinwheel Galaxy, a nice spiral-armed galaxy here. This is one that Michon did make some more detailed observations of. You can see that he wrote that it was a nebula without star, very obscure and very wide, 6 to 7 arc minutes in diameter, between the left-hand side of Bode's and the tail of the Great Bear. It's difficult to distinguish when illuminating the thread of the micrometer. That's the device that they use to measure the exact positions of these objects in the sky. So M101 would have been a small nebulous object to them. And of course, modern day picture shows that it has much more detailed spiral arms, a nice bright center to the galaxy, really beautiful and classic example of a spiral galaxy in the sky. M101 was observed and confirmed no problem. It was really M102 that created this great debate throughout history. So let me tell you a little bit of the story here. So when Pierre Méchain made his observations of M102, he didn't record the coordinates of the observation, nor did he provide much detail about what he saw. You can see here in the white box that this is literally what's in the catalog. There's no coordinates, and it says nebula near the star Omicron Boötis and Iota Draconis. It is very faint, and it is near a star of 6th magnitude. That's it. Not a lot of information to go by. And after the submission to the catalog, Messier went back, did some observations, and he hand wrote in some coordinates of right ascension 14.4 degrees and declination of 56 degrees. So in going back and looking at the sky near these locations and descriptors, astronomers found a couple of things. First, there is no nebula between Omicron Boötis and Iota Draconis. If you go along the line of sight of these two stars, which happen to be really far apart in the sky, you're not going to find a nebula or any interesting object in the sky, just other random stars. This is very peculiar, one, because there's no object there, but also because these stars are so far apart. It would have made more sense if Méchain had talked about two stars closer to use as a reference point. You have to pass by a bunch of other bright stars in the constellation to get to the line of sight of these two stars. It's just kind of odd that he would have chosen those two stars for reference. Also, if you go and look at the exact location that Messier wrote down for coordinates, you also don't find a nebula there. So something is going on, right? Somebody made an incorrect observation, is what it seemed like. And actually, Méchain and Messier realized this in 1783, and Méchain actually retracted his discovery of M102. He wrote in a letter, he said, you know what, I think I accidentally reobserved M101. M102 is not its own unique object, and I'm retracting my discovery. Now, this is fine. I mean, that definitely could be true, but it's very bizarre that these two gentlemen, who were very, very precise with all their measurements, would have made such a big mistake. So historians have gone back and looked at their handwritten notes and all of the information that we have about these objects, and they've realized a couple of things. First, the note of Omicron Boötis is likely a misprint. You can see that the Greek letter O, Omicron here, it looks an awful lot like the Greek letter theta. Theta would have a bar across the middle there. And if the star that he actually meant to write down was Theta Boötis, that would make more sense. Those stars are closer together, they would make better reference stars. And it was also noticed that in catalogs that the two had, Messier and Méchain, Omicron Boötis was mislabeled. So Theta Boötis was actually labeled as Omicron, and that might be actually where the mistake originated. Secondly, there's a nebula 5 degrees east of the coordinates that Messier had written down. And if you remember from a while ago, Messier has made 5-degree mistakes before by accidentally misreading star charts. So if you look between Theta Boötis and Iota Draconis, you do find a nebula. And if you use similar coordinates that are 5 degrees east of what Messier wrote, you actually do find something new. You find this object called the Spindle Galaxy in the constellation of Draco. And this is now what we believe both of the astronomers saw, and this is what is included as M102 in modern-day Messier catalogs. So there is still some debate amongst astronomers about this, but all of the investigating that was done really points to the idea that M102 was a unique discovery, and it's this really cool edge-on spiral galaxy in the sky. So the modern-day Messier catalog actually contains 110 objects. M104 through M109 were observed by Messier and Méchain and recorded via handwriting in their notes, but they were never actually republished as a full catalog of 109, or in this case, 110 objects. We know that the two observed up through M109, and M110 was added in 1966 by modern day astronomers. And if you remember back to the beginning, we saw M110. It was actually this satellite galaxy of Andromeda. And nobody really knows why it wasn't included in the original Messier catalog. They included M31, Andromeda. They included M32, the very first observation that Messier ever made. And we're almost certain that they would have seen this satellite galaxy of Andromeda, but it was never included in any of the original catalogs. So it was added as the 110th object, but not until the 1960s. So this now is the complete catalog. Astronomers refer to the Messier catalog as these 110 objects in the sky, most of which were originally observed by Messier himself. All right, so to wrap up our discussion of the Messier objects, I want to mention how you can get outside and look at the Messier objects and maybe even participate in a Messier marathon. This competition is held usually in March every year by amateur astronomers. And if you go outside on a weekend in March, the timing is just right so that if you stay up all night long, it's possible to view every single one of the 110 Messier objects. And astronomers usually have these big parties where they get together in a park or an observatory, and they do that. They stay up all night long and use small telescopes and try and get everybody to see every single one of the Messier objects. So if there's a local amateur astronomy club near you, you can definitely reach out to them, see if they're doing a Messier marathon and go participate. Or if you have a small telescope, you can just point it at things in your backyard and see how many objects you can see in a single night. If you want to get involved, the best weekend to get involved next year will be March 5th, 2022. And I think because of the timing, the first weekend in April will also work as well. And both of these weekends are new moon weekends. So the bright moon won't get in your way of observing any of the most faint objects. So that's the Messier catalog, the history behind it, and some examples of some of the cool objects that you can even see in the night sky. In next month's program, we'll talk a bit about some of the equipment that you can buy, small telescopes, binoculars, basically how to get started in amateur astronomy, and we'll come back to a lot of these Messier objects and talk about how you can observe them from your backyard in the night sky.